The rules of absolute value equations and inequalities are stated in this chart from the book. However, sometimes when we write it just in algebra, you have said that you find it a little confusing. So I'm going to give you a very easy way to understand this page. You can pause and you can read the properties. However, the trick that Ms. Hurley shared with me is when you are using the expression less than, you're going to use than to remind you that that sentence is going to be a compound inequality that uses the word and, because than sounds like and. If the sentence, the original one, says greater than, that is going to end up being an or statement. It's going to have that it could be either or. And would be graphed, that it would be a shaded in between the two solutions, or would be the solutions that would be shaded in opposite directions. If we look back here to see if that makes sense, greater than, greater, that turned out to be an or sentence. I had to write it as a compound with or. And this one is less than, and that turned out to be an and sentence. Let's see if we can solve some more using that little trick. So let's go ahead and solve this one. We have, again, this is just strictly an inequality. So we can say that x is less than 3. But if we want to solve our, go ahead and do the negative version, I'm going to multiply 3 times negative 1, so I need to reverse my sign. Now in my original sentence it says less than, so we can expect this to be an and equation. I'm going to go about solving them the same way, getting like terms together. So I'm going to add 4 to both sides. This would be that x needs to be less than 7, and this would be, got ahead of myself there, adding 4 to both sides again with our reverse sign because we multiply by a negative to get our negative 3. This solution would be x needs to be greater than 1. Now if you think about a number line, whoa, there's a wonderful number line there for you, trying to save time here. And I put my 0 in there. And my two solutions, 1 and 7. 1 would appear here, maybe, and we'd put 7 up here. 1 is to the left of left of 7. So you can see I'd have an open circle here. I'd have an open circle at those two solutions. And if you go back up here, it says x is greater than 1, so I'd start shading to the right. And then if I went ahead and I looked at this other one, x is less than 7, I would be shading to the left. And you notice then we would get it in between there. The shading would happen in between there. So I could rewrite this inequality to look like this. X is less than 7, but it is greater than 1. That's an and equation. If I go to this inequality, first of all, we have it that it's a two-stepper. So I'm going to do my like terms together first. So I'm going to add my 3 to both sides so that I'm only left with the absolute value phrase there. So now I have my absolute value of 2x plus 1 is going to be greater than or equal to 9. At this point I didn't do anything with negatives because I have not taken away the absolute value symbol. Now I'm just going to do the phrases instead to solve. So I have 2x plus 1, and I'm going to leave my sign the same, greater than or equal to 9. Now I'm going to try to do the negative of that. So multiplying by a negative sign, I would need to reverse my symbol to solve for negative 9. Now the original one said greater than, so we know this is going to be an OR statement. Go ahead and solve, like terms together again. I get for this one 2x is greater than or equal to 8. On this side, I get 2x is less than or equal to a negative 10. Divide by 2 because I want to solve for a single variable. Notice I'm using the same process all of the time. And again, the only differences with inequalities is that negative makes you reverse the sign if you are multiplying or dividing by it. There's my solution. Let me see if I can scoot that up just a little bit for you to see the graph here. My daughter's looking at me like I'm crazy. And I have that situated just so you can see the answers we ended up getting. There it is, an OR again. If I went to my 4, it's going to be a solid dot because it had the equal and it was greater than. If I go to my next solution, negative 5, solid dot again, but written with the x coming first, I need to shade to the left. That is an OR statement again. Part of our lesson has to do with a real life situation. We're going to talk about some drill bits. You work in a quality control department of a manufacturing company, and the diameter of a drill bit must be between 0.62 inches and 0.63 inches. Now, the goal of this example is to write an absolute value inequality. We're going to start out with something that might be a little bit clearer for you. The first thing is we're going to write a compound inequality. So if we know that it has to be between 0.62 inches and 0.63 inches, we would write that compound inequality like this here. So far, so good. Now, the next part is, though, we have to answer letter A. We need to then write that as an absolute value inequality to represent this requirement so that we could put different solutions into that. So, I just write from the book, it's just as easy. So we wrote our compound inequality. The next step for this would be to find the halfway point. The halfway point between 0.62 and 0.63, because those are both in hundredths, is we would go to the thousandth and put a 5 there for it to be the halfway point. After we found the halfway point, we want to subtract that halfway point from each part of the compound inequality, right? So we do the 0.62 minus 0.625. That needs to be less than or equal to the diameter minus the 0.625. And that needs to be less than or equal to the 0.63, the biggest it can be, minus 0.625, that halfway point again. In solving that, we would get that negative 0.005 is less than or equal to the diameter minus the 0.625, and it's less than or equal to a positive 0.005, which would mean it could be smaller or it could be larger by that much. Now we're going to simplify that, so we're really doing reverse of what we did when we were solving. And we are going to write the center here, the diameter, minus 0.625. That was the halfway point. That could be an absolute value because it could be the positive or it could be the negative of that. The difference could be either way. To me, this relates a little bit to 6.5. I'm sorry, it's the next lesson. I did it in the wrong order on the last class. So this inequality can be read as the actual diameter must differ by no more than 0.005 inches, or 5 thousandth of an inch. And that would be a very, very small difference. Oops, I have one more screen I wanted to go to. So the last one, I forgot letter B. Letter B asks then, what if we had a bit with a diameter of 0.623? Does that meet the requirement? We're going to go ahead and we're going to substitute that in for our diameter. So it becomes 0.623 minus 0.625. And if that is less than or equal to 0.005, we have a true statement. I bring up my calculator on the screen here, and we will go ahead and see if that is true. So 0.623 minus 0.625, that equals a negative 0.002. It's 2 thousandths of an inch smaller, and 2 thousandths is less than 5 thousandths. So that is a true statement.